Section 1.3, Venn diagrams, video 4. We will cover the following objectives. Perform operations with sets using the above definitions, which are universal set, union, intersection, complement, and set difference for 3 sets. Create Venn diagrams with 3 sets, and use Venn diagrams to display set relationships. Example 4. Let the universal set contain X such that X is an element of the natural numbers and X is less than or equal to 20. If set A contains the elements 2, 3, 5, 7, 8, 10, 13, 15, 17, 19, and 20, set B contains the element X such that X is a multiple of 2, and set C contains the element X such that X is a multiple of 5. Find the following. I would highly recommend creating a Venn diagram so that you know where each element of our universe is placed within the regions of our universal set. So first, let's label our sets A, B, C, and our universal set is labeled. How you should create this Venn diagram is start from the innermost region working outward, meaning I want to find the elements that are in the green. That region is the intersection of all 3 sets. So we need to find A intersected with B intersected with C. Now it would be easier first to find the intersection of 2 sets. It does not matter if you start with the intersection of A and B, or the intersection of A and C, or the intersection of B and C. The choice is yours. I'm going to find the intersection first of B and C. So I know that set B contains multiples of 2 that are less than or equal to 20, and set C contains multiples of 5 that are less than or equal to 20. Of course, we're only dealing with values that are natural numbers. So B intersected with C would be multiples of 2 and 5, which are 10 and 20. Now we want to intersect that with set A. Well, set A contains both 10 and 20. So take a minute first to recognize that B intersected with C is the region in yellow. We know that 2 values, 10 and 20, are there. However, we have even more information that if I'm looking at the intersection of all 3, I also have the values 10 and 20. So the elements 10 and 20 must be placed in the intersection of all 3 sets. Now this region that I'm highlighting in green, that would represent B intersected with C, not set A. And in this case, I would have no elements. Now let's find the following 2 regions. We need to find elements with the A intersected with B, not set C, and A intersected with C, not in set B. So let's look at each one at a time. A intersected with B, that is not in set C. So first, let's look at A intersected with B. A intersected with B would be elements that are multiple of 2 that are also in set A. In this case, it would just be 2, 8, 10, and 20. We already know that the elements 10 and 20 are in set C, so I must take those out. What's remaining would be elements 2 and 8 that are in the intersection of A and B, but not in set C. Similarly, we need to find what the elements of A intersected with C, not set B, would be. But first we need to find the elements in A intersected with C. So set C are multiples of 5. So we need to know how many multiples of 5 are in set A. Well, we see that 5, 10, 15, and 20 are all multiples of 5 in set A. To find the region A intersected with C not in B, we need to take out those elements in my intersection with A and C that are not in B. What remains are elements 5 and 15. Now we can look at our elements in set A. Set A contains the elements 2, which is taken care of right here, 3, which would be in the region where it's just set A, 3, 5 is taken care of, 7, 8 is already listed, 10 is already listed, 13, 15 is already listed, 17, 19, 20 is already listed. If we're looking at multiples of 2, 2 is already placed, 4, 6, 8, 10, 12, 14, 16, 18, 20 is already placed. For set C, we have 5 already placed, 10, 15, and 20. So it turns out in the region where we just have elements that are just set C, there are no elements in this section. Now we have to look at our universal set. So we have natural numbers that are less than or equal to 20. So we start from 1, which is not in any of my 3 sets. So it's outside of set A, B, or C. 1, 2, 3, 4, 5, 6, 7, 8, 9 would be outside, 10, 11 would be outside, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now we've created our Venn diagrams with each of our elements in our universal set. Part A. We need to find the complement of A union the complement of B intersected with C. This can be spoken as A prime union B prime intersection C. So first let's find A prime. Now A prime is all the elements in my universe that are not in set A. There's 2 ways of thinking of this. You can look at set A, compare it to the universal set, meaning go from my natural numbers from 1 to 20 and only write down those elements not present in set A. So for us, we would have 1, 4, 6, 9, 11, 12, 14, 16, 18. Now the other way to look at it is we know that A prime is all the values or all the elements in my universal set that are not in set A. So I can just X out or take out set A and see what elements are left. Well, as I see, I have elements 1, 4, 6, 9, 11, 12, 14, 16, 18. So there is more than one way of looking at this. Now we need to find B prime, or the complement of B. Whichever way you feel comfortable. So for us, that would be 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. we need to find A complement union B complement. So that's all the elements in A complement or B complement. So listing these out, we have elements 1, 3, 4, 5, 6, 7, 9, 11, 12, 13, 14, 15, 16, 17, 18, and 19. We need to intersect that with set C. So the intersection with set C would only be the elements 5, 15, and that's it. So our solution to A prime union B prime intersect C are the elements 5 and 15. Part B. I have retyped the problem and already put in the Venn diagram. A intersected with B, not C. So the elements that are remaining or in that region would be the elements 2 and 8. Let's see. We have B not the intersection of set A and C. So set A prime, or the complement of A, would be the elements, and we found this earlier, 1, 4, 6, 9, 11, 12, 14, 16, and 18. We need to intersect that with set C. So if I'm looking at the intersection with set C are the elements 5, 10, 15, 20. If you notice, there are no elements in the intersection of the complement of A and C. So it's the empty set. So what this means for our problem, we have B take away the empty set, which means B take away no elements. So what we have remaining is just set B, which is the multiples of 2. That leaves us with 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Part D. The universal set, not the union of sets A, B, and C, not the intersection of A complement, B complement, and C complement. So first off, let's think about the elements in A prime intersected with B prime intersected with C prime. So A prime we have listed several times earlier. So I'm just going to write the values out: 1, 4, 6, 9, 11, 12, 14, 16, and 18. B prime we found as 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So we found both of those values earlier. C prime we need to find. So we know that C is a multiple of 5. So if we're looking at our universal set, which is natural numbers less than or equal to 20, we need to take out the values that are multiples of 5. So we're left with 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, and 19. Now the intersection of these three values would be, you have a 9 in all of them, we have a 1 in all of them, and we have 11 in all of them. So we find that the A complement intersected with B complement intersected with C complement are the values or the elements 1, 9, 11. If you look, those are the values outside of my union of A, B, and C. The second part is we need to take out A union B union C. So we already know that we have our union would have been A, everything in set A, everything in set B, and everything in set C. I am taking that out of my universe. So I'm really just left with elements 1, 9, and 11. And our problem says we need to take those out also. So if I take those out also, what am I left with? Well, there are no elements. So what that means is we have a solution of the empty set. This concludes example 4.